terms of operations. Those are the 4 operations. So what we're going to do today is we're going to get a little bit wild and we're going to do composite functions. That means we are putting one function inside of another function, okay? Now, the notation will look a little bit different. If I ask you for the composition of 2 functions, the way we write it is like that. So as you can see, it's like g of x has actually gone inside f of x. So usually f of x looks like that, right? But we have completely replaced x with g of x. So what that means, in f of x, wherever we see an x, we replace it with g of x. Sounds complicated, it's really not, okay? Another way we can sometimes write it is like this with this little circle. Okay, that little circle means of. So if we see that, that would mean f of g of x. Don't confuse this for a multiplication symbol. If it's an open circle, it means composition. Okay? Okay, let's just get into it. So I have f of x equals 2x minus 2. Whoops, sorry. F of x equals 2x minus 2, g of x equals that. Okay, we're used to seeing that, that's fine. So now I want you to determine f of g of x. So again, if we usually have this, all that has happened is we have replaced x with g of x. So the way that looks, if I ask you for f of g of x, I take f of x, okay, and I write it down. And then I locate my x's in that guy. And in f of x, I only have one singular x, so this isn't bad. But I want to replace x in there with what g of x is. So that means I take this whole guy and he gets put in the spot of x. Okay? So if I rewrite that, I would have 2 times x, but I know I've replaced all of my x's with what g of x is. So I now insert or replace x with g of x. And that's it. We've done the composition part. We've inserted one function into another. And so now all we have to do is simplify, which means distribute that 2, and then clean up if you can, but we can't clean that up. That's a trinomial. It's done. We're done. Okay? So that's composition, putting one inside the other. We're going to do the same thing for b, but we're going to flip it. So for b, I want g of f of x. So that means if originally it was g of x, I am replacing any x in g with what f of x is. So you start with g of x. I'm going to start by writing g of x down. Okay. But I locate my x's in g of x. And I replace those with what f of x is. So I have to insert f of x twice. Okay? All right, so what is f of x? F of x is 2x minus 2. So I've replaced x with 2x minus 2, but my x is squared, so I have to square that also. And then I have plus 3 times x, which I'm switching out for f of x. So we just made it way more complicated. But we replaced any x in g with what f of x is. Now, when something is squared, it does not just mean you just put the 2 into both terms. It means you have to actually FOIL it, expand it. But then this 3 can just get sent in at the back there, and I get 6 and 6. When I FOIL this guy, I get 4x squared minus 4x minus 4x plus 4. And then I still have the 6x minus 6. And at this step, we just clean up. I have a singular 4x squared, negative 4x, and positive 6x would give me a negative 2x. And then my 2 constants, 4 minus 6 is negative 2. Okay, so does that make sense what we're doing? We're just putting one in place of the other. Not so bad. All right. Okay, let's do something with radicals now. So f of x is x minus 3, g of x is radical x plus 2. Determine the composite function, and also we're going to state the domain. Okay, so let's start with this guy. So this means the same as that. So I just want to show you that notation. F of g of x would look like that. So that means you start with f of x. You start by writing down f of x, but then we are going to insert g of x in, okay? So if I start with f of x, it is what? X minus 3, right? But wherever I see an x, I have to replace it with, oops, I have to replace it with g of x, okay? So let's do that. So that means f of g of x would look like this. I hit my x first, so I have to replace that x with what g of x is in its entirety, which is root x plus 2, and then that minus 3 just gets written down. Well, all we can do to clean this up is go 2 minus 3, right? The brackets around that really don't mean anything at this point anymore. There's no distribution to do, so we can just toss those brackets away. 2 minus 3 is negative 1. Okay? We always have to state restrictions whenever we have a radical or whenever we have a denominator. You need to state restrictions. Okay? So I need this to be greater than 0. So that's it. That's pretty simple. X has to be greater than or equal to 0 because that's what's in. Just X is underneath. That's pretty simple. It's important to find the restriction because the restriction will be the same as the domain. I asked you for the domain, okay? So the domain of this guy, we did this a bit on the first day. You can find the domain separately. The domain of that guy, that's just a straight line, hey? A linear function. So that would be X as an element of reals. But this guy, his domain would have that restriction on it. That's a radical function. So it would just be like the half curve that's only in the positive area. And remember, did I say on Monday, whatever day I taught this, whoever has the more strict rules, like we have to go with that guy. Okay, so this would be the domain of the composite function as well. So find your restriction. Your domain is the same. X has to be greater than or equal to 0. And then from there on out, it can be whatever it wants. Okay, so restrictions and domains go hand in hand. Okay, if you can find the restriction, you can find the domain. All right, this guy here. So now I want g of f of x. So g is the boss. Okay, he comes first. He gets written down first. And then f of x goes inside of g of x. Okay. So if I always just like writing down what g of x is. I just like the visual of g of x. I see there's only one x I'm going to have to replace. So now I'm ready to do that. So g of f of x would mean radical. And then my x is replaced with what f of x is. And f of x is x minus 3 plus 2. There's no simplifying you can do there. The x and the 3 are protected under the radical. That's it. That's the final answer. Okay. I asked you for the domain again. So for the domain of this guy, it's this new guy. Okay. So the restriction comes from this now. So your restriction has changed a little bit. So your restriction, the x minus 3 has to be greater than or equal to 0. Therefore, x has to be greater than or equal to 3. And that is the same as the domain. Okay. All right. Let's get crazy, Xander. You see what I did for C? I'm doing f of x. I'm going to put f of x into itself. Okay. So I'm going to start by writing down what's f of x. X minus 3. Wherever I see an x, I'm going to now plug in what f of x is again. So that would mean that f of x would be x minus 3 minus 3. The brackets don't mean anything. They're not protecting anything. You can drop those brackets, simplify x minus 6. Okay, so that's my final answer. What's my restriction on this composite guy or my domain? Do I have a restriction anymore? No, because I don't have a radical. That would just be a linear function, right? So the domain, there's no restriction, okay, but the domain would just be that freebie. Okay? All right. Now we're going to do something a little bit different. I'm going to be giving you numbers now. But again, I give you f of x is something, g of x is something. Okay, great. But now I want you to find f of g of 2. What do you think that means? What would I do first? Any ideas? Find g of 2. Okay, so you know, like with BEDMAS, if you have a lot of brackets and numbers, you kind of go to the more internal bracket first and then work your way out. With PEDMAS, it's the same thing here. You go to the more internal thing, figure out first what is g of 2. So we would plug 2 in, figure out that answer first. Then we do f of that answer. Okay, so first things first, I want g at 2. So I just go to my g equation, 2 squared plus 2. All right, that gives me 6. So the answer to g of 2 is 6. So really what I'm asking for now is f at 6, because I just figured out that g of 2 is actually 6. So I'm kind of like replacing the g of 2 bracket with what I found, which is 6. So f of 6 would be 4 minus 6, negative 2. How simple is that? Okay. This is just different notation. I'm trying to get you used to different notation. G of f at negative 3 means the same thing as that. Okay, you keep the g first, the f second, the negative 3 is the number we're using. So this means I have to figure out that inner bracket first. What is f at negative 3? So you go to your f, it's 4 minus x, so 4 minus negative 3, that equals 7. So now I actually want g at 7 because I have figured out that f at negative 3 is 7. So I really want g of 7. And g is x squared plus x, so that's 49 plus 7, 56. Am I going too fast? Is this okay? All right. Okay. Okay, I'm going to get wild again, Xander. Did you know I was going to look at you? He knows. Okay, I want g of 1. So I want to figure out what's g at 1, get that answer, and then do it again on g. Okay. G at 1 would be 1 squared plus 1. That's 2. So I just figured out g at 1 is equal to 2. So now I'm really asking what's g at 2? 2 squared plus 2 equals 6. Good? Yes? Okay. All right. This is where it can get a little bit wild. Okay. I am telling you that h of x is a new function, and I got that new function by composing f and g. Okay, I put g inside of f. I'm going to give you some information, and you have to find g of x. So we did this yesterday. It's like I give you the answer, and one of the functions, you have to find the missing function. So we have to find g of x. So you got to stay with me on this one, okay? I give you the answer. I tell you what the answer was. So in my equation, I know h of x is the result of composing f and g. I'm just essentially rewriting this. That's just what I did there. But I know what h of x is. So I'm going to write down my left-hand side, replace h of x with what I know h of x is. Now, we have to kind of think about what we would have done with f and g here. If I was composing f and g and I was putting g inside of f, if this is f, I would have highlighted my x and put a g of x in there, right? That's what we've been doing this whole lesson, putting g inside of f. So on my right-hand side, I know that I would have 1 over x squared, but it wouldn't actually be x anymore. I would have put g of x in there and then squared it. I just don't know what g of x is, so I leave it as a g of x. Am I making sense? Okay. From here, you have to solve, okay? You have to solve for g of x. So you have to get that guy who's on the bottom and also squared. You have to get them up top, undo the square, get them all alone. Any ideas what you do? What I see is I actually have perfect square, perfect square, perfect square, perfect square. Do you guys agree? One's a perfect square. And then because of these guys, those are also perfect squares, right? If everything is a perfect square, I can do that to both sides and it won't get messy because they're all perfect squares. It'll work out nicely. So I would still have 1, but now it would just be over x minus 2. I've square rooted each thing. 1 over g of x. I've essentially just gotten rid of my 2's, right? Now, did you guys know when you have a fraction equal to another fraction with no other busy stuff around, just fraction equal to fraction, you can just flip them on both sides? Did you guys know that? I'll show you. Can I prove it to you? What if you have this? Flip them. They'll still be equal. Okay? So you're allowed to do that here. You can flip both fractions, and then we would just have 1's on the bottom. We technically wouldn't have fractions anymore, right? I'm done. I was looking for g of x, right? G of x is isolated. G of x was equal to x minus 2. Done. Okay. We're going to do another one just to make sure we've made sense of it, because I'm going to go throw in extra radicals now. Okay, same idea. I know this h of x was created by doing f of g of x. Okay, but I know what my h of x is, so I replace my left side with that. Now, what would I have done over here? I would have taken whatever x was in my f of x, right? And I would have replaced it with what g of x was. So I'm going to do that again. Radical x, but instead of x, I'm replacing it with g of x, but I just don't know what it is yet. Okay, that's way easier. I don't have fractions. What do I do to solve for g of x in this case? You have radicals on both sides. What can you do? I'm going to square both sides. Gone, gone. Okay, x squared minus 2 is my g of x. Okay? All right. Last question. This is as tricky as it can get, okay? Because you will see that g of x is a rational expression, okay? So we have a polynomial over to our trinomial over top of a binomial, and I want to find f of g of x. So that means I take f of x, and wherever I see an x, that's what I have to do. Replace that x with that entire thing. All right. So f of g of x would be x squared plus x minus 2 all over x minus 1. But then you still have this little stinker hanging out. He does not get added with that and make a 0. Absolutely not. You wouldn't be able to do that. This doesn't have a common denominator, okay? He's kind of on his own. Okay, so at this point, you have to simplify and solve this guy. we did these in pre-calc 20. In pre-calc 20, if I asked you to simplify this, I would have said, well, that's over 1. If you want to be able to add stuff to the other guy, he needs to have a common denominator of x minus 1. So you can actually add them together and get them over top of all the same denominator. So I would have x squared plus x minus 2 plus 2x minus 2. I've just distributed that 2 in there. And that is all over x minus 1. And your left side is still this guy, okay? Listen to me. Do not mess with your left side. Your left side has no numbers in it. I see students trying to do this because we're so used to doing that, hey? You're going to multiply those together. How? How are you going to do that? You can't do that. So we have to go another route here. Any other ideas how I could potentially simplify this, clean it up? Raphael? I'm sorry? Cross out x minus 1 with what? Okay, so I think what you're trying to say is I should clean up my top, make it a trinomial, factor the trinomial, and pray that I can slash. Yes, you're absolutely right. Okay, so x squared plus 3x minus 4 is what happens when I clean up the top. And then this would be x plus 4, x minus 1. Look at that, x minus 1. Those cancel. So in the end, my f of g of x whittled down to just x plus 4. Very quickly, I'll do the restriction up here. I just have that denominator, so x cannot equal 1. Okay, last one. Let's just do it the other way around, okay? So now, I forgot a bracket here. I want g of f of x. So you start with g of x. He's kind of the boss, but holy smokes. I have to locate every x in g of x. You okay, Elroy? I have to locate every x in g of x and replace it with f of x. So let's roll. So it's x plus 2. Oh, gross. My first thing I see is I have an x plus 2, and then I still have to square it. I'm going to FOIL. But then I just have a regular x plus 2, and then I have that minus 2. On the bottom, I just have an x, so x plus 2 minus 1. Okay. FOIL first. X squared plus 2x plus 2x plus 4. And then the plus x plus 2 minus 2. I'm just going to drop the brackets on the bottom. 2 minus 1 is 1. I just cleaned up the bottom a little bit too. Let's clean up this trinomial. X squared is alone. I have 2x, 2x, 1x, so I have 5 of those guys. And then I have 4 plus 2 minus 2, so that's still just 4 over x plus 1. Like Raphael said before, let's factor and hope we can slash. That's the only simplifying left. X plus 4, x plus 1. Perfect. And I get that my answer to g of f of x was the exact same as the other guy. They're both x plus 4. Okay, and our restriction here changed as well because my denominator is different. My denominator is x minus 1. So x minus 1 cannot be 0. X cannot be 1. No, sorry. It was x plus 1. Pardon me. I'm looking at this guy. Okay. So that's it. And that's chapter 10. Done. So I'm going to ask you one more time. We are confident in not having a work period for this tomorrow. Test tomorrow. Your test is long paper. The first page is only multiple, like it's front and back multiple choice. I think there's 10 total because there's some graphs, I think. And then it's just one single page of these questions, not even the backside. Okay, it's pretty light. All right, let me get your required questions. And 507. All right, you are going to do number 1. We'll do number 2. We'll do number 4ACE. And then we'll do 7. Okay,